This is the Kenyan teacher. It is our pleasure to present electrochemistry as tested in KCSE Chemistry Paper 1 between the years of 2013 to the year 2017. Welcome as we take you through the expected responses to the questions from the topic. We begin with the year 2013. Question number 6. Part A. A student electroplated a spoon with copper metal. We were asked for 1 mark to write an equation for the process that took place at the cathode. Now, before we answer this question, let us take some time and draw the probable setup that the student would set up. So we shall have our electrolyte being any aqueous solution that contains copper ions. In here, we shall have our anode. The anode will have to be made of copper strip. The anode is where oxidation takes place. So we expect this copper strip, which forms the anode, to go into solution as copper ions through loss of electrons in a process that we call oxidation. Now, the spoon that is being electroplated would then be placed at the cathode, because this is where reduction takes place. So we shall expect the copper ions to be reduced to copper metal, which will then deposit on the spoon. So we would then connect the copper strip to the anode or to the positive terminal of our cell, and the spoon would be connected to the negative terminal of the cell. So this would be our cathode, the spoon being electroplated, and the copper strip would be our anode. How do we name these? We name these depending on which electrode has been connected to the terminals of our cell. This is positive and that is negative. Now, at anode, we've just agreed that there would be oxidation. So the copper strip would be oxidized to copper ions, which then go into solution via loss of 2 moles of electrons. At cathode, we shall have reduction taking place. So the copper ions in solution shall accept 2 moles of electrons to form copper metal, which then deposits on our spoon. So once a candidate has understood this process, we can now go ahead and answer our question. So the equation for the process that took place at cathode therefore becomes copper ions accepting 2 moles of electrons to give copper metal, which then deposits on our spoon for 1 mark. Part B talked about quantitative treatment of electrolysis, and we were asked to calculate the time in minutes required to deposit 1.184 grams of copper if a current of 2 amperes was used. So to answer this question, The first thing that candidates need to understand is the interpretation of this equation here, which represents the process of deposition of copper at cathode. So the interpretation of this equation is that to deposit 1 mole of copper here, which is equivalent to 63.5 grams of copper, we need 2 moles of electrons, which are equivalent to 2 Faradays. This is supposed to be equivalent to 2 multiplied by 96,500 coulombs. That would be the understanding of our equation written in part A. So from here, we understand that to deposit 63.5 grams, we shall need quantity of electricity which is equivalent to 2 multiplied by 96,500 coulombs. But from the equation or from the question, we are told we only needed to deposit 1.184 grams. So how much quantity of electricity do we need? Through cross multiplication, we shall have 1.184 multiplied by 2 times 96,500, then we divide by 63.5. This is supposed to give us 3,598.61 coulombs. Now, from here, once we've gotten our quantity of electricity, we now relate it to our formula. Quantity of electricity is given by current in amperes, that is I, multiplied by time in seconds. So we already have our Q as 3,598.61. This should be equal to current we have as 2 amperes. The only thing we miss here is time. So with this relation, we can go ahead and get time. And time would be given by 3,598.61 divided by 2. That gives 1,799.3, but they are seconds. Remember, we've agreed that time is given in seconds. If you look at our question, we are told to calculate the time in minutes. So time in minutes, we will need to divide this by 60, and that would be equivalent to 29.98 minutes for us to score the 2 marks. Quite easy for a candidate who understands the Faraday's law. But again, we are here to simplify these, and we believe it has been useful for those who are following us. Let's then proceed to the year 2014, where electrochemistry was tested again in question number 5. Explain how conduction of electricity takes place in the following. Part A, we have iron metal, and part B, we have molten lead 2 iodide. Now here, we need to understand that we do have 2 types of electrical conductivity. There is one that we call metallic conductivity, and there is one that we call electrolytic conductivity. So metallic conductivity is the one that is in metals, and we use what we call delocalized electrons as the particles responsible for conduction here. When it comes to electrolytic conductivity, this is exhibited by our electrolytes. and the particles responsible here are usually what we call mobile ions. So in our case here, iron being a metal would have metallic conductivity, and molten lead 2 iodide would have electrolytic conductivity. So here, a student would then just explain to the examiner that for iron metal, conduction of electricity is by the localized electrons for that 1 mark. And when it comes to molten lead 2 iodide, we would talk about mobile ions for the next mark. That leads us to question number 4 for the same year 2014, which also tested the topic electrochemistry. Sodium chloride, that is dilute sodium chloride solution, was electrolyzed using inert carbon electrodes. We are supposed to name products at anode and cathode. So here we will need to start by identifying the ions that are present in that solution of sodium chloride, and it is dilute. So here we have 4 ions. That is sodium ions, chloride ions, and we also have hydrogen ions and hydroxyl ions. Now, to determine which ions are going to be discharged at the anode and cathode, we usually take our candidates through 3 factors. One of them being position of ion in the electrochemical series, where we normally say that at anode, it is always the hydroxyl ions that are usually discharged. That is when we look at that factor alone. At anode, it is always hydroxyl ions. Then at cathode, looking at that factor of position of ion in the electrochemical series, we always advise it is the hydrogen ions that are being discharged, always, except in cases where we have copper ions, silver ions, or mercury ions. That is as far as factor 1 is concerned. Now, looking at the second factor, which is usually concentration of the ion in the electrolyte, we say that concentration only affects discharge at anode. So in cases where we have chloride ions and hydroxyl ions migrating to anode, and then you are using a concentrated sodium chloride solution, then instead of hydroxyl ions, we shall then discharge chloride ions because of their higher concentration. Then we also have a third factor, which is nature of electrode used. So for this part, because we are using dilute sodium chloride solution, we shall go by factor 1, which says at anode we shall always discharge hydroxyl ions, and at cathode we shall always discharge hydrogen ions. So the question asked us to name products at anode. Now, once we discharge hydroxyl ions, we know we produce oxygen gas and water. So we have oxygen gas that will come out as bubbles. Production of water may not easily be detected. So the examiner expected a candidate to go for oxygen. But if you went ahead and write that oxygen and water is surely also produced. Moving to cathode, we shall talk about hydrogen gas for the next mark. And I believe I've explained why it happens so. Now for part B, we are told that the experiment was repeated, but now using concentrated sodium chloride instead of dilute one that we used in part A. So we are then asked to write half equation for the reaction that took place at anode. So we have agreed that when you use concentrated sodium chloride at anode, we shall not discharge hydroxyl, but this time we shall discharge chloride ions due to their higher concentration, and concentration affects discharge at the anode. So we then write chloride ions, aqueous, being discharged through loss of 2 moles of electrons to give us chlorine gas. So we shall balance with a 2 on chloride ions to balance the charges for that 1 mark. We now cross over to the year 2015, question number 11. Dilute sulfuric 6 acid was electrolyzed using platinum electrode. These are inert electrodes. Name the product formed at anode and give a reason for your answer. This question is almost similar to the previous one. So we shall start by identifying ions present in dilute sulfuric 6 acid. That is hydrogen ions, sulfate ions, and we also have hydroxyl ions. So, as agreed in the previous question, at anode we shall discharge hydroxyl ions. And the moment you discharge hydroxyl ions, you produce oxygen gas. So those are our products: oxygen gas and water. We are asked to give a reason for our answer. You will simply tell us that hydroxyl ions are discharged. Hydroxyl ions are discharged to produce oxygen and water. We are not asked to write any equation here, so that would do for the 2 marks. Same year, 2015, question number 18 was still from our very easy topic of electrochemistry. Study the standard electrode potentials in the table below and answer the questions that follow. So we have reduction of copper ions, positive 0.34, reduction of magnesium ions, negative 2.38, reduction of silver ions. This should be single positive. There was a printing error there. Positive 0.80, and finally reduction of calcium ions, negative 2.87. So first question is asking us to identify the strongest reducing agent. And here it's very easy to do. What a student needs to know is that these standard electrode potentials, the one which is the most positive is the strongest oxidizing agent, and that which is most negative becomes our strongest reducing agent. So what a candidate needed to do is just to come to our E0 values here and check the one which has the most negative value. And you can see the most negative is 2.87 negative, and our answer here now becomes calcium for 1 mark. Part 2 or part B. What observations will be made if silver coin was dropped in an aqueous solution of copper 2 sulfate? Now, this question can be answered from two fronts. One is using our usual reactivity series, where we know that silver is below copper and therefore less reactive than copper, and for that matter, it will not actually displace copper from its ions. But because we've been given these, the examiner expected us to use actually these values to help us answer our question. So the first thing that we needed to have done is to assume that when we drop silver into a solution that contains copper ions, then a reaction would occur where silver would actually displace copper, as represented by this equation here. So we write it this way, and then we balance the charges with a 2 on silver and a 2 on silver ions. So we shall assume that this reaction actually would take place, and then we work out the E cell. We see whether it is negative or positive. If negative, the reaction will not take place. But if positive, the reaction will take place. So according to this equation, moving from silver to silver ions is oxidation. And moving from copper ions to copper metal would be reduction. We would then go ahead and calculate the E for the cell if we were to construct a cell of silver and copper and then connect the two. What are we going to read in the voltmeter? So E cell is given by E reduced minus E oxidized. E reduced, according to our equation, is copper. Copper has a value of positive 0.34. E oxidized would be silver. Silver has a value of positive 0.80. This would give us E cell value of negative 0.46 volts. From here, we see that E cell is negative, and for that matter, this reaction represented by this equation here cannot proceed. So we would then conclude that there would be no reaction. To answer our question, there would be no reaction. Why would there be no reaction? There would be no reaction because EMF that we've just calculated here is negative to get our 2 marks. But of course, after you've shown the examiner that you know what you are doing by calculating the EMF. We can replace EMF being negative with the words that silver is less reactive, or silver is below copper in the reactivity series. Hence, cannot displace copper 2 ions from the solution. The solution that we have here is copper 2 sulfate solution. So it was rather a very long question, but we are here to explain to our learners how to approach a similar one should it be tested. We proceed to 2016 this time round, the year 2016, and the topic was tested as question number 1. Effects of electric current was being investigated here by passing the current through some substances. Of course, inert electrodes were used and connected to a bulb in a circuit. So the table below shows the substances used and their states. First experiment, potassium carbonate solid. Second experiment, copper 2 sulfate solution. Third experiment, sugar of course, solution, and the fourth experiment led to iodide molten. So, for the first part of the question, in which experiment did the bulb not light? You agree with me? Experiment 1 and experiment 3. The bulb would not light. We are told to explain our answer in part B. So it's simple. In experiment 1, we have potassium carbonate, but in solid state. So ions in our potassium carbonate are rigidly held within the crystal. They are rigidly held within the crystal, which means they are not mobile. They are not mobile. So they are rigidly held within the crystal, hence immobile, and cannot conduct electric current. That would give our first mark. Then we explained that in 3, of course, we know sugar is molecular. Sugar is molecular, even in solution. Hence, it lacks mobile ions. So there will be no conduction there as well for another mark. Let's proceed now. We are crossing over to 2017, and let's have a look at question number 3. Question 3 for 2017, Chem Paper 1, tested the dry cell. I believe our candidates have an idea of how it works. So we are told to start by naming part B. Part B is what we call carbon, or we can use graphite instead, and it is an electrode for 1 mark. Then second question, part labeled A here is a paste. Of course, I believe you know the composition of that paste. We shall not go into that because we made a video about this cell some time back. The title of the video is Dry Cells. Kindly check that out to learn on the components of the dry cell and how the dry cell works to produce electric current. Now, we are told part labeled A is a paste. Give a reason why it's not used in dry form. Very, very easy. We don't use it in dry form to allow movement of ions. Of course, we can replace this with to have it as an electrolyte, and we can even write that ions are immobile. Ions are immobile in dry form. Any of those 3 would have earned ourselves that next mark. What is the purpose of the zinc container? Zinc container simply acts as the negative electrode. This we know quite easy for that last mark for question number 3. We finally end our video by looking at question number 22 for the same year 2017. In part A, we were asked to define an inert electrode, and this is one which does not, inert electrode is one which does not react or does not affect the products of electrolysis. Does not react or does not affect the products of electrolysis, or does not participate in the reaction. Either any of those would earn the mark. Part B, state the products formed when brine, we know brine is simply a concentrated solution of sodium chloride. So in here, we shall have sodium ions, chloride ions, hydroxyl ions, and hydrogen ions. At anode, this has been discussed earlier, we shall discharge chloride ions because of their higher concentration. So the products at anode become chlorine gas. The reason is that instead of hydroxyl ions, which are usually discharged, this time we shall discharge chloride due to their higher concentration. For the cathode, we usually have our usual hydrogen gas. And with that, we've come to the end of our video where we've taken you through the testing patterns of the topic electrochemistry for the years 2013 to 2017. Keep it the Kenyan Teacher for more reviews, and thank you so much for being part of us.